So in this video we're going to look at calculating relative formula mass. This is a GCSE chemistry tutorial. So the first thing that I've done here is I've put down a definition of relative atomic mass, because we need to know what relative atomic mass is before we can stick them all together and work them out as a relative formula mass. So the average mass of one atom compared to 1/12 the mass of one atom of carbon-12. Now that sort of long-winded definition, it tells us that carbon is our standard in the periodic table. So we're comparing the mass of all of our atoms back to carbon-12. Now what this means is if we take an atom of carbon-12, what we're saying is, like with the degrees Celsius scale that we set, the freezing point of water is 0 degrees Celsius. We're comparing everything against that. We're doing the same thing here with carbon. So we're setting carbon as kind of our starting point that we compare everything to. And what we say is one atom of carbon-12 would have a mass of 12 grams per mole. So in other words, 1 mole of carbon atoms weighs 12 grams. Now it's really useful because it means we can compare all the other elements in the periodic table back to this. So for example, if you have a look at your periodic table, you can see that the mass of a hydrogen atom is 1. And what we say there is that that is 1 gram per mole is the mass of hydrogen atoms. So 1 mole of hydrogen atoms weighs 1 gram. We'll have another example here. So if we look at magnesium, for example, so magnesium atoms have double the mass of carbon-12 atoms. So 1 mole of carbon-12 atoms weighs 24 grams. So it's just a simple way of starting and making a comparison between our different atoms. So this is the mass of the individual atoms. Now, relative formula mass is the total mass of all the atoms in a compound added up. So what we're going to do is we're going to have a look at how you would calculate the relative formula mass of different compounds. So I've got a few examples here. So we've got magnesium oxide as our first example. Now if we have a look at this, what we're going to do is we're going to look at the different types of atoms in the compound, and then we can add up their relative atomic masses to find their relative formula mass. So the first example here, we've got 1 magnesium atom, we've got 1 oxygen atom. So the mass of 1 magnesium atom is 24, the mass of 1 oxygen atom is 16. So these two added up gives that formula a total mass of 40 grams per mole. Now, what we'll do is we'll continue working through these, but one thing that I should point out is that we're going to refer to this as relative formula mass throughout. Now, sometimes you see this written as RFM here. Sometimes you see it written as MR like this. Strictly speaking, this is relative molecular mass. I'm going to refer to relative formula mass throughout, simply because these are different formulae. None of these are actually molecules, so these are all ionic compounds. Now, MR, relative molecular mass, is only applicable when we look at molecules. So when you look at the unit on structure and bonding, there's just a little bit of a definition issue there, and so just want to be careful with that. So let's stick to relative formula mass for this one. Now if we have a look at this example here, we've got 1 sodium atom, 1 oxygen atom, 1 hydrogen atom. So the mass using your periodic table of a sodium atom is 23. The mass of an oxygen atom is 16. And the mass of a hydrogen atom is 1. So adding all three of these up, again, we're actually going to come to the same mass. So 1 mole of sodium hydroxide, NaOH, weighs 40 grams. So we have 40 grams per mole is the relative formula mass of sodium hydroxide. If we have a look at this one here, sodium sulfate, we can see that this time we've got 2 sodium atoms, we've got 1 sulfur atom, and we've got 4 oxygen atoms in this. So for our sodiums, it's 2 times 23. For our sulfurs, it's 1 times 32. And then for our oxygens, it's 4 times 16. If you do the calculation and you add them all up, you'll come to a total mass of 142 grams per mole. You can use your calculator to do this. Let's look at the last one, the last T. We've got magnesium here, so we've got one magnesium atom, and this has a mass of 24. We've got two nitrogen atoms, 2 times N, so 2 times 14 for the mass of the nitrogen atoms. And then here we've got 2 times 3, so we've got 6 times the oxygen atoms. So that's 6 times 16. And if you do this as a calculation, you will end up with a total mass of 148 grams per mole. The final example here, this time we've got 2 aluminiums. So that's 2 times 27 for the aluminium atoms. We've got 3 times the sulfurs. So that's 3 times 32. And we've got 3 times 3, so we've got 9 oxygens here on this last one. So that's 9 times 16 for the oxygens. This leaves us with a total relative formula mass of 294 grams per mole. Now when you're doing this in exams, make sure that you include all of your workings in the question, because if you do make a mistake, you can get error carried forward marks. So if your final relative formula mass doesn't add up to the correct answer, you'll at least get some marks as you work through the question. I hope you found that one useful. Just a quick short video. Please like and subscribe and share these videos and try and get more of them out there.